Doing good. Sahil, have you joined? Okay, Hazik, roll number 25. Are you there?
Yes, sir.
Okay. तो कैसी तैयारी चल रही है? पढ़ाई करते हो? अब आपके एग्जाम्स होने वाले हैं.
सर चल रही है ठीक ठाक.
Okay. Muntaha, roll number 2.
Yes, sir.
कैसी पढ़ाई चल रही है?
सर चल रही है, हो रही है.
कब से एग्जाम्स है?
तो अभी नहीं हो बोला मैं.
अच्छा. Where are your CRs? Zarka is not there and Sahil is also not present. Please just inform your friends, colleagues that they have to join the class now by mail or by putting a message in the group. Maybe some of you might not see the message, just call them. Both the CRs are not present. Shabir Hussain, roll number 23.
Yes, sir.
तो पढ़ाई चल रही है?
Yes, sir. चल रही है.
Okay. I guess students are getting added up. So, okay, Zarka, you are quite late. Are you there?
Yes, sir. So actually, I'm sick today. So I was sleeping.
Everything all right? Just a normal flu?
Yes, sir. कल घर पे बहुत काम था तो उसकी वजह से काफी थक गई तो it's just that.
Okay. Okay, Sahil, have you joined now? Sahil, have you joined?
Yes, sir. Assalamu alaikum.
Walaikum salam. You're late.
Yes, sorry, sir.
Okay. Okay. Actually, you are supposed to do this last chapter by your own, but I just wanted to give few lectures on this chapter. But then, due to our other engagements these days with regard to election, we have election duties and trainings every now and then. Till the time this election will be over, we will be quite busy with that. In next week, I most probably won't be available because in that week we have elections, DDC elections, as all of you must be knowing about it. DDC elections, municipal sarpanch elections. So we have we have duties with regard to that. I probably would suggest you people to start working for your end term exams, and whatever we can complete with regard to the last chapter, I'll do that. But at the same time, you should spend some time on that last chapter by yourself also, because actually this chapter was supposed to be done by you only, but I'll try as many classes to conduct as possible. But as of now, we do not know about the next week onwards, because due to, as I already said, due to elections. So you should start reading books and checking what are the topics that are in this chapter. And in the meanwhile, whatever time I can get, I'll try to conduct classes, and but most probably it won't be much, maybe 1 or 2 classes I can give you more. But don't rely on them, just start working on your syllabus now, because
Excuse me, sir.
yes.
सर एक रिक्वेस्ट है.
हाँ बताओ.
सो जो आपने प्रीवियस पैटर्न सेट किया था ना एग्जामिनेशन को, मतलब पहले एक क्वेश्चन सॉल्व करो बाद में दूसरा आएगा, सो वो ऑनलाइन.
हाँ.
सो प्रोबेबली मतलब मुझे नहीं लगता सर उसके लिए थोड़ा पैनिक होते हैं, मतलब पैनिक उसमें जब वो सॉल्व करना पड़ता है थोड़ा पैनिकनेस होती है, उस तरह से हम स्मूथली नहीं कर पाते. अकॉर्डिंग टू मी सर. So
no problem, we will be changing the pattern of exam this time. Maybe it will be a Viva plus your both.
Thank you, sir.
If this creates you problem, no issues, I'll try to rectify that.
Thank you, sir.
Okay, dear. Okay, fine. We will get back to the class. Fazan, shall we start? Sorry, Sahil.
Yes, sir.
Okay. So we were talking about in our previous class, we talked about kinematics and kinetics. We got an idea what do we understand by kinematics and kinetics. And in the broader picture, we got to know that. Can anybody tell me what is the main difference between kinetics and kinematics? Anybody? In our previous class, we primarily discussed about both the things, in which we firstly discussed what is dynamics actually. How does it make how is it different from static? Dynamics is basically it's concerned with the bodies that have accelerated motion, right? That have accelerated motion. And then we studied about kinematics, and we said that kinematics is basically the study of the geometry of the motion, right? Kinematics is study of the geometry of the motion. And then kinetics is basically the study of the force that causes the motion, right? Whenever an force is applied to any body, right, that force, that the study of that force is called as kinetics. And then the change geometry, then the study of that geometry which has been incorporated due to that force, that study is called as kinematics. Okay, so now we will be studying about what do we understand by, as I have already told you in the last class, we will be studying about rectilinear kinematics and curvilinear. Okay, fine. Firstly, we will be discussing about rectilinear. we have seen the definition of rectilinear kinematics in the previous classes. In previous class, it basically means when any particle is moving along a straight line path. Right, and a particle is moving along the straight line path, and here we say, and regarding the particle, we say that that particle has a mass, but it is usually of negligible shape and size. That's why we term this as particle. And we will be also studying about a group of particles or about a reached body. Primarily, we will be discussing about the particle as of now. So, in order to understand this rectilinear kinematics, as we already have understood that this is the study of what? Geometry of the motion. This is about the geometry of the motion. Now we will try to understand what does that mean, geometry of the motion. What are the things that include in geometry of the motion? Firstly, at any point, whenever we have a particle, at any point, we will be discussing about three things. Primary thing is we will be discussing about particle position. We know particle position is to be described when we talk about the geometry of the motion. Okay, and then we have velocity, and thirdly we have acceleration. Right, these are the three things which we should be knowing when we talk about the geometry of the motion. When we talk about the geometry of the motion, I'm not talking about the geometry of the particle, geometry of the motion. So firstly we will be discussing about a, that is position. Now what does position mean? Position, it is basically whenever we are discussing position, it has some reference point. Let's say we have this point, and we say that the particle is somewhere here, which is at a distance of s, which is at a distance of s. And this is basically, what is this? This is the position of that particle. Let's name this point as O. And here it has some coordinate axis. That is, coordinate axis is S. S is the coordinate axis. That means it is at a distance of S. This is the coordinate axis that we describe this with. And here the origin and here the origin basically, which is point O, on the path is basically fixed. It is fixed point. O is a fixed point, and from this point, that is point O, we have the position coordinate. We have the position coordinate S. We have position, this is what this is called as position coordinate X. And it is basically, what is it used to? It is used to specify the location of the particle. What is this S used to? We say that a particle is at a distance of S. That means this particle has some position where it is placed, and where it is placed at a distance of S with reference line of O, which is a fixed point. And usually it is a distance. We usually measure it in meters. And here the sense of direction is basically, we have direction because it is moving in the positive direction of x. If we say this is positive, this is your x, this is y, we say whenever a particle moves from point O towards the right, it is positive, and if it moves towards the left, we say it is negative. And and similarly, whenever a particle goes in the upward direction in the y, we say it is a positive positive movement, a displacement. And if it is goes down, we say it is negative. Fine. So here, likewise, if here the particle has moved towards the right, so we can simply say that in this case, S is what? S is positive. S is positive. Since the coordinate axis is basically at the right of the origin. And similarly, if we say, if it is going towards the left, then we say the displacement here is negative. Okay. And from this position coordinates, what we can actually come to the conclusion, which is displacement. We will be able to calculate the displacement from this position vector. Okay, and this position is a vector quantity, as you already know, because position has to be vector
Excuse me, sir.
quantity. Yes.
So sorry to interrupt, but somebody is waiting in the waiting room.
I know that, but I don't know. It does not have any name or anything. It has some.
सर वो पहले भी ज्वाइन कर रही थी बट उसका ऑडियो कनेक्ट नहीं हो रहा था. अब उसने अनइंस्टॉल करके वापस इंस्टॉल किया, तभी शायद नहीं आ रहा होगा नेम एंड रोल नंबर.
Just tell her to get admitted one more time. Just leave it and get it admitted one more time.
Okay, sure. Sorry, sir.
Okay. So here, what we will be discussing, about displacement. We'll be discussing about displacement. Now, what does displacement mean? Here, the displacement, as you already know, that displacement of a particle is basically defined it is defined as change in position. It is defined as change in position. Displacement is change in position. For example, now we have this similar particle which is at a distance of s, and we say, let's say, this point particle which was at a distance of s, it has now changed its position and it has gone to a point which is s dash from point O. It has now, from S initially, it has now moved to another point, which is at a distance of S dash from the origin O. Therefore, here we say this is what? This is your delta S. And delta S is what? It is displacement. Delta S is change in position. Initially, it was at a position, let's name this as, it was at a position A. Now it has gone to position B. So this means displacement. This means displacement. When we say that it has moved from one place to another, that is displacement. So here, when we have to calculate this displacement, we simply calculate this displacement by S dash minus S. This is the displacement. Therefore, this amount is the displacement. When we have to calculate it, we simply say S dash is the total distance which the particle has moved, and S is the initial position where the particle was actually. So here again, we have positive and negative type of displacements, right? We have positive displacements when the particle is actually moving in the positive direction of x. In the positive direction of x, we say it has a positive displacement, and in that case, we say it has a positive displacement. And the displacement can go even in this direction. The particle can be initially at a point S, and then it can move back to some another location which is in the negative direction of x-axis. And in such case, what we say? We say it is negative displacement. And in that case, we say it is negative displacement. Fine. Here again, the displacement of the particle is, as you can see, it is also a vector quantity. And specifically here, the distance traveled is a positive, in the positive direction, or it can also, wherein the length have increased from what it was actually. And in the second case, when we have negative displacement, we say that the length has now decreased from the initial point where the particle was actually. Okay, and this was about the displacement. And then apart from displacement, we should also know what actually happens to velocity. What is velocity now with respect to the same particle initially moving from point O0, which was the reference line, and then it has moved to point A, and we could easily say the position have changed. It is a particle position, and then we calculate the displacement. Now we want to know what actually happens with the velocity. Now, if the particle has moved through any displacement delta s, if it has moved through any displacement delta s during the time interval, which time interval? Delta t. Now this particle has taken time t to move from point A to point B. Then how we say the average velocity of the particle? Then if we have to calculate the average velocity of the particle, average velocity of particle during this time interval. How do we define that? We simply define that average velocity, V average, that will be equal to what? It will be delta S divided by delta T. Right? Velocity is the displacement with respect to the time interval. This is what? This is an average velocity here, what we are talking about. Now, if we say that the particle has taken very smaller value of time t, that means it's in seconds or it's in microseconds. It has reached, it has moved from point A to point B in a very small instant of time, in a very small, smaller, with the smaller value of delta t, right? If the delta t is very small, the interval is very small, then we can simply say, we can actually calculate by this, we can calculate the instantaneous velocity. We can calculate instantaneous velocity. So here what we can see, if the time limit is very small, we will be able to calculate what? We will be able to calculate instantaneous velocity. And that instantaneous velocity will be actually equal to when we limit when we say we limit it to what? We limit time almost equal to 0, and we say delta s by delta t, and that will be equal to what? ds by dt. This is your instantaneous velocity. When you want to calculate the instantaneous velocity of any particle at any particular time, you will be able to calculate the instantaneous velocity. Or in other way, you could be able to calculate with regard to what? With regard to the distance it has covered. Right, and when you are talking about distance with which it has covered with respect to the time taken to reach from one distance to another distance, then in that case you say that velocity is called as average velocity. Okay, here you can simply say it is instantaneous velocity. Fine. Here, as I have already told you, let me draw it again. As we have already mentioned it again, we have two different points. One is this and another is this, and it has moved in this direction, that is positive velocity, and this is your delta s. Fine, the delta s is the displacement, and this is your velocity. This is your velocity. Here again we will be able to say that which is positive velocity and which is negative velocity. If it is moving towards the right end, then it is positive, and if it has moved from any point towards the left, then we say that it has a negative velocity. Okay, here we can say the magnitude here we can say the magnitude of velocity is speed. Here in this case, when we talk about this, can we say the magnitude of the velocity is speed? And we how do we what are the units? It will speed distance will be meter, and it will be time will be per seconds. And here we say the magnitude. We do not say we cannot say velocity is speed. Velocity is not speed. We say the magnitude that the velocity has is actually speed, and we express that in terms of meter per second. And we sometimes also called as we also use the term average speed here when we talk about this velocity. But the average speed is always a positive term, and the difference here is we define the speed as total distance traveled by a particle. Total distance traveled. Uh, uh, can anybody tell me what can be the probable difference between a speed and a velocity? Sahil, can you tell me what is the difference between speed and velocity?
So speed में हम consider करते हैं distance. Distance is distance from point A to point B. It may not be shortest. It may be whatever path has been acquired by the body. But displacement is the shortest distance between 2 points A and B.
Can you repeat? I didn't get it.
So I said in distance we consider speed, and sir.
Yes, you can.
In speed we consider distance. Distance is the actual path that is taken by the body to go from point A to point B. But in velocity we consider displacement. Displacement is the shortest path from point A to point B. But in speed we consider distance. Distance is like the actual path that has been taken by. It may not be the shortest.
Can we say displacement and distance is same? Because in velocity you say displacement, but in speed you say the distance traveled.
So in rectilinear motion we can say that
okay,
because we move in a straight line in that case.
Can anybody add on this? Can anybody add on this?
Sir, velocity is the vector quantity, and this speed is scalar. Means velocity has a direction.
Okay. Anybody else?
But the magnitude of velocity is same as speed. Magnitude तो same होता है, लेकिन difference ये direction में आता है.
Okay, good. चलिए, good. So now what we can do is you have got a concept of average speed, this average speed. It will be simply what? It will be the total distance. What will be average speed? Average speed can be simply total distance traveled by the particle, right, divided by the elapsed time. As Sahil and one more student have already said, what can be the probable differences between the two, between what we call as velocity and the speed. It is simply when we talk about average speed, it is the total distance traveled, right, divided by the total time taken. Whereas in case of average velocity, we are talking about average velocity, which is actually the displacement. It is displacement, not the distance traveled. It is the displacement divided by the time. So now we will come to one more thing. that is acceleration. Now we will try to understand what do we understand by acceleration here in this case. Now we already know that the velocity of any particle is basically known between the 2 points, right? Velocity can be different at 2 different points. Let's say here in this case, what we had this particle again, point O, and initially it was somewhere at this place, then it moved to this place, and we say let's say it has a velocity v when it was at point A, and then it has a velocity when it was at point B. It has v dash. Okay, and we here say it is in the positive direction. Acceleration is in the positive direction of x coordinate. So in order to calculate our average velocity first, A average will be simply what? Change in velocity divided by change in time. How much time has it taken? It is basically average velocity of any particle during the time interval with delta t. Therefore, we can simply say it will be the change in velocity, which was earlier v, and then it has moved to velocity, some other velocity, v dash. Now, in order to find out what will be the this is average, what will be the instantaneous velocity? Can anybody tell me what is the difference between the average velocity and instantaneous velocity? You already know about these things. This is just a recapitulation. Can anybody tell me what will you understand here now by instantaneous velocity? Instantaneous is when you are limiting the time, when you are saying that the time is quite less. The time taken from velocity v to v dash is quite less. It is very less. It is quite instant. In that case, you will be able to calculate your instantaneous velocity and instantaneous acceleration when your time limit is very less. Time limit less means initially you were having your acceleration was, as you already know, acceleration was delta v by delta t, and you say you are limiting it to what? You are limiting delta t to 0. And then in that case, your instantaneous acceleration will be simply equal to what? dv by dt. Differential of velocity and differential of time. And which further can be, if we say we have two equations now, we have calculated, we have seen with regard to the velocity, our velocity was what? ds by dt, and our acceleration is what? dv by dt. In velocity, it is rate of change of what? Displacement with distance with regard to the time, and then in acceleration, it is the rate of change of velocity with respect to the time. And with regard to these two formulas, we can simply say that acceleration is what? Acceleration can be written as d acceleration d by dt into v. How much is v? V is ds by dt ds, and then it will be equal to, acceleration will be equal to t square s divided by dt square. Okay, your acceleration can be written as, in terms of the in terms of the distance, it can be written as d square s by dt square. Okay, but here if you see both the average and instantaneous acceleration, it also can be either positive or it can be negative. As I have already told you, it can also be in such a way so that when we say while we have given the previous example also, that acceleration can be negative acceleration can be also there, which is also called as deceleration, and that can be when the particle is basically slowing down, or we say the speed is decreasing. We say when let's say we are in a vehicle and we have to stop now the moment we will start applying brakes, right, the acceleration will now change into deceleration. Initially it was accelerating, now it will get decelerated, and in that case your acceleration a will be in the negative sense because it has been in the opposite sense. So we can also here conclude with one more thing, and that is we can also, if we have to draw a relationship between all three of the quantities, what are the three different quantities? We have three different quantities. We have ds, we have dv, and we have dt. Sorry, we have dt is already there. We have ds, we have dv also, and what we have velocity, and we have acceleration. And if we want that there should be a relationship between all the quantities means the displacement, sorry, the distance, the velocity, the acceleration, then in that case we can simply draw with a conclusion from this equation, that is, let's name them as equation 1 and equation 2. We can simply write equation 1 as dt is equal to ds by v, right? And we can also write equation 2 as dt is equal to dv by q, sorry, a, acceleration, right? And we can correlate them, and we can simply say we know dt they are both same. ds by v will be equal to dv by a, and we can say that ads is equal to v dv. Fine. This is one more relationship between the acceleration. You have now acceleration, you have distance, you have velocity, and rate of change of velocity. When you have a correlationship between the velocity, acceleration, and the distance, you will be able to solve many problems out of this. Now we will be talking about one more thing here before we will go into solving a problem, that is when we have constant acceleration. Now can anybody tell me what do we understand by constant acceleration? Anybody, what do you understand by constant acceleration? What is constant acceleration? Nobody? It will be actually, it can be defined when we talk about constant acceleration, because now that we have all the three equation, or we have already formulated some kinematic equations. These are also called as kinematic equations. This is your third equation. We have already mentioned this is your equation 1. Okay, and when we have drawn all the and this is your equation 2. Sorry, with these equations that we have already formulated, now if we say the acceleration is constant, that means let's say a is equal to as ac. Now ac means constant. In that case, as we have already known, the acceleration will, all the accelerations will actually become constant. That is, we have acceleration a, it will become ac is equal to dv by dt, right? And ac ds will be equal to vdv, right? These acceleration will now change to constant. And thirdly, we have this third kinematic equation. Okay, these three are called as kinematic equation. Now, firstly, when we talk about these accelerations, what do we have now? We will have to integrate it basically to obtain formulas that relate what? That relate out of these formulas, we have to make it at a constant acceleration. Now we need to integrate it to make it to what? To make it to a constant and velocity, and we need to calculate s as well, and we have t. These are the unknowns that we have: AC velocity, distance, and we have time. So, firstly, we will be saving, we will try to find out what actually happens with these equations when we talk about velocity as a function of time. When we talk about velocity as a function of time. Okay, when we talk about when we say that velocity as a function of time, velocity as function of time. In that case, what happens actually? Velocity as a function of time. Velocity as a function of times means what happens with AC? AC will be simply equal to dv by dt. Okay, AC is dv by dt. Constant velocity means that initially velocity as a function of time, and we talk that constant acceleration. In that case, what will happen? We assume that initially v is equal to as v0. We assume what? V is equal to as v0. When at what instant? When time is zero. When time is equal to as zero. And in that case, we will start to integrate it now. Right? We will start this to integrate now. Now this will become AC dt will be equal to dv. Right? Simple. I haven't done anything as of now. Now if I integrate it between the limits, what? V to v0. V to v0, which is the initial velocity and the final velocity. At time is when time was zero, because we are saying it's a constant acceleration. So here our it will become dv, it will be equal to uh, dv will be equal to ac dt, and we will be integrating it, and velocity will be integrating from v naught to v, and here at the time interval of 0 to t, at the time interval of 0 to t, this will become now, because v and v0, you have two different velocities now. You have two different velocities. It will be simply become v minus v naught. That will be equal to what? A, C, and dt integral of dt will be simple t. And your equation velocity will be equal to v naught plus AC t. Cup when you have constant acceleration. This will be your case when you take velocity as a function of time. When you take velocity as a function of time. Now, if I take position, initially I have taken velocity, now I take position as a function of time. I take position as a function of time. What will happen in that case? When I take position as a function of time. Okay, then in that case, now you have to see position as a function of time. That means s position is what? S and t, and we should also get acceleration, right? Therefore, we can simply say we will have to integrate what? Same equation velocity, that is v is equal to ds by dt. Position as a function of time. This is position as a function of time. Okay, and but here in this case, we will be simply when we integrate this, if we integrate this, as we already have seen, assuming here we will be assuming what? That initially s is equal to as s naught. S is equal to as s naught when time t is equal to as 0. When time t is equal to as 0. Because we are taking position as a function of time. Position, that is initially it was was equal to s naught, and at time when t is equal to as 0. And in this case, now we will be having what? We will be having this equation, as we have already seen that this velocity is now what equal to what? This velocity is equal to what? From the previous expression, it is v naught plus act. It is equal to v naught act. So we can simply write this thing as we can write ds is equal to as, because v is equal to as, we already know v is ds by dt. So ds is equal to as v dt. And we integrate them s naught to s. And we integrate this also v dt from 0 to time t. So this will be equal to, now ds is what is ds? ds already is s to s naught. That will be equal to s minus s naught. This will be equal to integral of v. We already know what is v. Integral 0 to t. V is now v naught plus ac t multiplied by dt. Okay, that will be equal to s will be equal to s naught plus v is already there. It will be v naught multiplied by dt, and its integration will give us v naught t plus ac into t. T will be t square by 2 when you give its acceleration. AC will be there. That means half of AC into t square. Okay, and again here we have constant acceleration. This is your second expression. When you have position as a function of time, you have another expression in order to calculate the distance here with respect to the what being position as a function of time, and we have a constant acceleration. We have a constant acceleration. These expressions are only when you have constant accelerations. Now, thirdly, we will be talking about initially we had velocity as a function of time. Second, we had position as a function of time. Now we will take velocity as a function of position. Velocity as a function of position. Velocity as function of position. Now, in this case, velocity as a function of time, we have to solve for t, right? In our previous equation, which was v naught. So here we had this equation firstly. We had this equation firstly. V is equal to as v naught plus ac t. Right, this was the first equation. We can solve it by putting the value of t also and substituting it in the value of substituting here, then substituting in this equation. Or we can simply, we have third expression also, which was v dv which we have already calculated, that is equal to as AC ds. This is the third kinematic equation. And we assume here what? We assume here initially V is equal to as V0. But at what point? At when S is equal to as S0, S0. Okay, these are the conditions if you apply it to this equation and formulate a equation with respect to constant acceleration and being velocity as the function of position. And in that case, you have VdV, you have ACDS, you integrate both of these. We integrate these two equations and it becomes VdV simply. VdV will be from V to V naught, right? And then AC ds will be from what? S naught to S, right? And you will get an expression out of this which will be equal to V square equal to V naught square plus twice AC S minus S naught. Again, we have constant acceleration. This will be our third expression when we have velocity as a function of time. Now you will be out of these three expressions with regard to the constant acceleration, you will be able to solve many problems, right? You will be able to solve different problems having different parameters. Now here what we say, these equations are very useful only when we say acceleration is constant and at time t0 and s is equal to s naught and v is equal to as v naught. For example, I'll give you an example here. Let's say constant acceleration motion. What is the example of constant acceleration motion? Suppose here when we have some object freely falling towards the earth, when we have some freely falling object which is holded at some point and then it will start to fall on the earth. Actually, what happens in that condition? I have a apple in my hand and I'm holding this apple in my hand, and at some instant of time I'll open my hand, and what will happen to that apple? It will fall down towards the earth, right? And but at the same time I'm saying that the distance of the fall is very short, right? Then the downward acceleration of the body, which is being very close to the earth, is actually constant. And we already know that acceleration is actually equal to how much? It is 9.81 meter per second square, right? That is the acceleration that will be there. But at the same time, when we have a very shorter distance, what will be my velocity? And at the same time, there won't be velocity, but there will be acceleration, and that acceleration will be constant at that instant of time. Okay, this was regarding rectilinear motion. Now please, you should do various problems on this. How do we actually calculate different okay, fine, let's do one problem, a simple one, then we will go to collinear. I think we have quite less time left for this meeting. Okay, let's say here a car, we have this, a particle is moving, or let's say a car is moving here we have this car. It has an positive acceleration, and it has a positive velocity. Fine, and it is moving from left towards the right in a straight line. But in a straight line, let's say this is the reference point O, in a straight line, and such that for a short time, for very shorter period of time, its velocity has been defined by this equation, that is 0.6 t square plus t meter per second. Okay, now what we need to do is we need to determine its position. We have to find its position, and we also need to find its acceleration. When time is 3 seconds, when time is 3 seconds, and it is also been given that when t is equal to as 0, s is equal to as 0. I hope you understood the problem. We have to find out what? We have to find out its position, whereas the velocity has been given in the by the means of this equation. We need to find out here the position and the acceleration when time t is equal to as 3 seconds. But at the same time, it has been given when time is equal to 0, distance s is equal to as this is basically distance. What is this? This is distance from point O. That means when time was 0, this car was at point O. This car was at point O. So here, by the coordinate system that is in front of us, car is moving in the positive direction. So here the car's position, as we already know, in order to find its solution, we know that velocity will be equal to ds by dt. Right? Velocity will be equal to ds by dt. Here we are correlating velocity, we are correlating s, and with respect to the time. And it has been given that s is equal to as 0 when time t is equal to as 0. Right? It has been given that t is equal to as 0 when s is equal to as 0. And in this case, this velocity has been equated to what? 0.6 t square plus t. This is the equation that has been given here. Fine. So here we will just integrate it now. We will integrate it, the velocity factor, and it will be simply equal to, this velocity will be equal to ds by dt will be equal to now 0.6 t square plus t. Okay, and we can say that ds integrating from 0 to s will be equal to integrating with respect to the time, that is 0 to t, 0.6 t square plus t multiplied by dt. Okay, and we will be able to calculate our s, and that because we have 0 and s, it is 0 and t. Your 0 and s will be simply equal to, your s will be equal to, calculate this quickly, do the integration, that will be equal to, s will be equal to 2, it will be 0.2 t cube plus 0.5 1 by 2 t square. Okay, this will be your distance s. Now this is the equation that we had made out of the equation that we had given for the velocity. Now it has been told that we need to calculate when t was how much? When t was 3 seconds. Putting the value of time t is equal to as 3 seconds, our s will become 0.2. T is 3 seconds. Okay, that means 3 raised to the power of 3 plus 0.5 multiplied by 3 raised to the power of 2, that will be this s will be equal to, calculate it quickly, how much is it when t is 3? Calculate this quickly.
9.9.
9.9.
9.9.
Okay, this is 9.9 meter is the distance that it has traveled in 3 seconds with respect to the equation that has been provided for velocity. Now, if we want to calculate the acceleration, can anybody tell me what will be the acceleration?
4.6.
It will be simply, you have equation A is equal to as dv by dt. Give the v is already given to you, that will be equal to differentiation of velocity, that is 0.6 t square plus t, right? And you will get your acceleration, that is 4.60 meter per second square. This is your acceleration. Okay. Now, please solve as many problems as you can with regard to the concept rectilinear continuous motion, straight line motion. And we will be discussing now with regard to the curvilinear motion. What does this mean? Can anybody tell me what we have studied with regard to the curvilinear motion up till now? We have already given some concepts regarding the curvilinear motion. As the name itself gives, it's the self-explanatory thing. Curvilinear motion, anybody? Can anybody tell me what is curvilinear motion?
So when a particle moves along a curved path, motion of a particle along a curved path.
Motion of a particle along the curved path. Now, as per you, what will actually happen with regard to the position, to the velocity, to acceleration, displacement? What will be the changes, as per you? How will how will the geometry of the motion get changed now? In what perspective? Yes, any idea? Any idea? Now here in a curvilinear motion, what we say when a particle, let's say a particle has moved in a circular path. Let's say it has a it was somewhere here from point 0 path. This is what is this is your path, and it has moved, and let's say the path origin is somewhere, the position is from this point to this, and the reference point is, let's say, here now, and it is at a distance of r, and you have traveled some circular path, that is s. Now here this particle that is somewhere at point this, let's name this as a, it has moved along a curved path actually, right? This path is actually curved path, and now we know that uh, now we have to basically formulate particle position. We have to formulate what actually happens with velocity, acceleration. Now, firstly, we will try to analyze what basically is position. What is position? Now here, this particle has actually, it was being located at some point on the space curve, and that space curve or this path function has been supposed to be formulated in the form of that function is s with respect to t. And here the position of the particle that is basically measured from a fixed point. Which is that fixed point? That fixed point is O. This is basically actually designated to be a position vector, right? When r is equal to as rt. And we notice here that we have both the things. We have magnitude and we have direction of this vector. And it will now both of them will change as the particle will move along the direction, along the curve. Now when it has started moving along the curve, r will also change and the position of the that particle along that path will get changed, right? So how we will define now here displacement? Now in 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 order to find out the displacement, suppose there is a time interval which is very less. For example, very in very shorter span of time, the, where we have this particle has now moved, let's say, from one position to another position. Let's say this is the another position, and the change in the distance will be delta s, and r has now changed to r dash, and you will be having delta r. They are both position vectors. Now here, as I have already told you, that suppose that we have a small interval of time delta t. It in that time interval, this particle has moved delta s. Small interval of time, the particle has moved what? Delta s along the curve, and that to a new position now. And that new position here will be, that new position is actually what? That is r dash. And what will be r dash now? What will be your r dash? R dash will be simply how much? It will be 1 r plus delta r, because delta r will be what? R dash minus r. We can write this new position will be r dash, that will be r plus delta r. And here the displacement delta r, here the displacement, it basically, what does it represent? It represents the change in the particle position. What is the r dash? Or r dash is the particle's position, right? It is the particle's position that has now been changed, and it is basically represented by, we can simply represent it by delta r is equal to as r dash minus r, right? As simple as that. Nothing new in this. So here this will be our displacement. This is the displacement that while moving from a point A, as I have already, this is point A to point B, where we have the position vector which has changed from R to R dash, and the path that it has covered from A to B is delta S. That is the distance. So here, finally, when we have to calculate the velocity, velocity will be simply what? When we have to calculate the average velocity will be delta R by delta t at any instant time t. Sorry, at any time t. This is your average. And when we have to calculate the instantaneous velocity, instantaneous velocity is basically determined by saying that instantaneous velocity, what do we say when we call any velocity to be instantaneous? That is at the specified time, at any specified, and that time is equal to as, when we say that time is we are taking that time to be as 0, and consequently delta r will approach the tangent to the curve. Delta r, in that case, it will approach from initial point to the final point. It will be tangent to the curve. This is your tangent from point A, and that will be simply equal to, when you are limiting what? You are limiting time t, that is v is equal to as limit time t0, and we say delta r by delta t, that is equal to as instantaneous, and we say that v is equal to as dr by dt. This is equal to as, this is your instantaneous velocity. Now suppose, since dr is basically the this is your v. Now we say dr is basically what? It is the tangent of the curve, and the direction of v is also direction of v. This is also said to be as tangent of the curve, right? This is also said to be the tangent of the curve. Here the magnitude of v, which is now, I have supposed it magnitude of v, which is actually what? Speed. It is actually realized that the length of this straight line segment, that is delta r. Delta r, it approaches the arc length. It approaches what? Arc length, and that arc length is delta s. This is your arc length, delta s, as delta t tending to 0. And when we apply this delta s, that is to be the arc length, we say velocity is equal to as limiting delta s, which was delta r. This is actually equal to as, this is similar to what? Arc length, which is limiting delta s by delta t. And we can also say that v is equal to as ds by dt. Okay, thus here the speed can be also obtained from differentiating of the paths with respect to the time. And similarly, acceleration also. Acceleration can be simply, expression for acceleration can be when we talk about a constant acceleration. For example, here we have two paths. We have two paths. One is point A and another is point B. It will be having two different velocities. It will be having velocity. Here it will be having, let's say, V, and here in this case, we will be having V dash. We will be having two different velocities. So here average velocity will be simply what? Your A average will be equal to change of velocities at two different points with respect to time, right? And instantaneous velocity will be equal to, at particular time, instantaneous acceleration will be equal to a, that will be equal to dv by dt. And this expression can also be from the above two expressions. It can also be written as, acceleration can be also written as d square r by dt square. Is dt square. Okay, along these can be the accelerations along the most defined paths. Now you will be having also problems on the same concept, which you will do yourself. So this is enough for today, but I expect that you should be doing certain problems on the same topic, and most probably I'll be giving you assignment in day or two, which you will have to submit. I'll be giving you 2-3 assignment, which will be in accordance with the final evaluation of the course. I'll assign some marks to these assignments, please do them in the stipulated time. Most probably, I'll be either sending you day after tomorrow. I'll be sending you on day after tomorrow. And at the same time, please go through the problems that we have here. Is that okay?
Yes, sir.
Okay, then fine. Take care of yourself and study and go through all your lectures, because in next month you will be having exams. And try to find out what are the other these topics in this chapter. And these are, you will have to study hard. This was about the particle, right? And then you have to find out what actually happens with rigid bodies. Same kinematics and kinematics, rigid bodies. And then primarily you have to see what is D'Alembert's principle, and you have to find the problems that you have in D'Alembert's principle. And finally, you have work energy principle, which you will do yourself. And let's see, if I get time, I'll also try to get through these classes. Is that okay? Anybody having any problem? Any issue? Sahil, anything that you want to ask?
No, sir.
You have all the classes that you have been taught. You have the soft copies of these videos.
No, sir, I don't have them.
There was somebody who was recording those lectures. Who is that? I guess Basit was his name.
Yes, sir, Basit was doing that.
Is he present?
Yes, sir, he says.
Basit, what about those lectures? Abdul Basit, roll number 24.